This is lesson 10.6, and we're going to look at how you calculate volume of a sphere. So if you look first of all right here, we have a cylinder with a sphere inside it. So it's really important to note that we're saying that the sphere has a radius, and we're calling it r, and that the cylinder has the exact same radius. And so the sphere is actually sitting so that the top of the sphere here is hitting the top of the cylinder, and the bottom is hitting the bottom of the sphere hits the bottom of the cylinder. So that means that the distance from the top of the bottom is 2r. 2 of the radii make up the height of that cylinder. So let's talk about the volume of the cylinder first, and then let's talk about how the sphere sits inside the cylinder. So, our volume is always going to be volume equals area of the base times the height. And in this case, since it's a cylinder, we replace capital B with pi r squared times the height. And now we're going to put in what we know. And so pi stays the same. The radius is r, so we square that. And then the height, rather than saying h, I'm going to use this right here. And so it's 2r. So if I just do some quick simplifying here, 2 is here, pi here, and r squared times r is r to the power of 3. You add the exponents together when you're multiplying. All right, now, here's the tricky part. So what we have here is the volume of the cylinder. Now, unfortunately, to actually derive the formula for that sphere, you have to use calculus. And since you're in geometry, that probably wouldn't be appropriate. So we're going to estimate. We're going to use inductive reasoning here. And so if you just focus right now on this half right here of the cylinder, and if you had to take a guess, what guess would you make that the cylinder, that half of that sphere fills up? What part of the cylinder? And the answer, I'm hoping, would be 1/3 and 1/3, which means that the sphere takes up 2/3 of the cylinder. All right. And like I said, if you actually wanted to derive that, I would have to use calculus, which probably isn't appropriate. And so what we do is we take our formula for the volume of that cylinder, and we multiply it times 2/3. And so let's do that. Here we go. 2/3 times 2 pi r cubed. And in the end, 2 times 2 makes 4/3 pi r cubed. And that is the formula for volume of a sphere right there. Alright, so you definitely need that formula. You should write that down in your notes, because we are going to use that in all of the problems that we work out in this section. So volume of a sphere, 4/3 times pi times r cubed, r to the power 3. Alright, we've got two examples that we're going to work out. The first example looks like this. These are not simple ones, but let's try this out. It says, as an exercise for our art class, Mona has cast a plaster cube. So there it is on the right-hand side. It's 12 centimeters on each side, so each length, width, height is always 12. And she needs to carve the largest possible sphere from the cube. And the question is, what percentage of the plaster will be carved away? So what percentage of that cube will be wasted? So if we first of all find the volume of the cube, so the volume of the cube would be area of the base, so 12 times 12 times the height, which is 12. So if I get out my calculator, I'm actually punching in 12 to the power 3, and I get a volume of 1,728 cubic centimeters. Now let's talk about the sphere. We got our new formula here, 4/3 pi r cubed. So 4/3 times pi, and the radius, so the whole distance is 12. That means the radius has to be 6, so 6 cubed. So I am just using my calculator. I'm cubing 6, and I get 216. I'm multiplying by 4/3, and I get 288 pi. Now, since I'm going to be comparing it to the volume of the cube over there, I had better multiply this out. So I get an approximate answer of 904.32 cubic centimeters. Okay, now remember what the question was asking. The question was asking what percentage of the plaster will be carved away. So we need to figure out what will be thrown away. So if I take the volume of the cube, which was 1728, and if I subtract 1728, and if I subtract 904.32, the volume of the sphere, I get 823.68 cubic centimeters. So that is what will be thrown away. And if I want to calculate percentage, then I need to take the amount that's thrown away, 823.68, and divide by the total volume. And if I do that right now, I get 1728. If I round off, it's about 48%. So about 48% of the cube will be thrown away after carving away to leave a sphere there. Alright, so that's a great problem. I'd like to emphasize also that, I've been trying to work on that strategy where even when we did area, find the volume of the whole, find the volume of another smaller part, and then subtract. It's a great strategy that keeps coming up over and over. So let's try one more example here. So here we have it's a plastic part of a toy. So if you have a Buzz Lightyear at home, he has a plastic helmet that goes over his head. And so what we're going to do is we're going to use the same strategy we used in the last one to find the volume of this, except for we're going to find the volume of the outside, and then we're going to find the volume of the inside half of a sphere there, and then we're going to subtract the two. So let's start with the outer shell, and volume equals 4/3 pi r cubed, and in this case then r would be 5 inches, so 5 inches. Now some of you may be saying, wait a minute, he's forgetting that it's half of a sphere. I'll take care of that at the end. Alright, I'm 5 cubed times 4/3 is 166 2/3 pi, and this is cubic inches. The inner one, I'm going to do the same thing. And I haven't forgot that it's half yet. I'll come back to that. And this would be 4 cubed. And if I quickly do that, times 4/3, I get that the volume would be 85 1/3 pi. Okay, so both of those numbers would be as if the sphere is a whole sphere, but that's not the case. So we need to do one last thing to them, and that would be to divide them in half. So let's take the last one first here and divide by 2, and the volume of that half would be 42 2/3 pi cubic inches, and the volume here would be, let's do 166 and divide by 2, and you get 83 1/3 pi cubic inches. All right, and so that would be the volume of both of those. If I subtract the two to figure out the volume of just the part in between them, I do 83 1/3, and I subtract 42 2/3, and I get 40, and I get 40 2/3 pi, and that would be the volume of the the part in between the outer and the inner. So I'll color that right here. That would be the volume of all of this right here. All of that. All right. So these two examples may be examples that are a little bit more difficult, but they're still really good practice. And go ahead and take that formula and see if you can work on the problems that I have for you for the day.